solving some trigonometric equations. This is a few more examples from the other video I had. So let's get started right away. Example 1. We're going to solve 3 sine 2 theta minus 2 sine theta equals 0. All right, so we're solving this equation and we're solving it for, we want the particular solution and we want the general solution. So we're going to go for the whole thing. When I'm looking at that, I don't have any squares, so no factoring, right? Nothing is squared. So then I'm looking for other things. And when I look a little bit closer, I can see that right there, this will be an identity I know I have, right? So I'm going to rewrite sine 2 theta as 2 sine theta cosine theta. This is the double angle identity for sine, but then here, this was still multiplied by 3, so we cannot forget that. So we're going to say 3 times that, and then minus 2 sine theta. Here we don't need to do anything, equals 0. Okay, now I'm going to distribute that 3, so it's going to give me 6 sine theta cosine theta minus 2 sine theta equals 0. And at this point, I'm looking and I'm thinking, okay, well, there is still something I could be doing. I have a sine here and a sine here. I could be factoring this out. And in fact, I have a factor of 2 here. And there is a factor of 2 in that 6, right? Because 6 is 2 times 3. So I'm going to factor out 2 sine theta. And so 6 divided by 2 will be 3. So 3 cosine theta. And then 2 sine theta divided by 2 sine theta will be 1. So minus 1. All right, and now I have a product. And I multiply two things and I get a 0. So that's the zero product property. So we're going to say, okay, then 2 sine theta equals 0. Or 3 cosine theta minus 1 equals 0. And then we're going to finish up. So divide by 2 on both sides gives you a sine theta equals 0. And then you're thinking, well, where is the sine equal to 0? And that will be right here at 0 and at pi. So sine theta is 0 when theta equals 0 or pi. So those will be two of my particular solutions. And then I'm looking on that side here. So I'm going to add 1 to both sides and divide by 3. So cosine of theta is equal to 1 over 3. Oops. Now that makes me frown, right? This is not in the unit circle. So we're going to use the cosine inverse, right? So we're going to the arc cosine. So theta is going to be equal to the arc cosine of 1/3. Now 1/3 is positive, and so I know that the cosine is positive in quadrant 1 and 4. I don't know where that angle is. That will give me a ratio of 1/3 here, right? But I know there is somewhere in quadrant 1, somewhere in quadrant 4. So I'm going to keep that in mind. And I'm going to say, well, then theta, and you could leave this as is. And in fact, the solution then would be plus or minus here, right there, right? Because this one will be your positive angle, that will be your negative angle, right? Positive, negative for the same angle. So that would actually be a particular solution and we will be done, right? If you put arc cosine of 1/3 in your calculator to kind of get a value for that, you will get, let's see what I did when I put it in my calculator a minute ago. I had plus or minus 1.231. oops, 2, 3, 1. And this is in radians, so I'm not going to put a degree symbol there. That's radians, right? And plus or minus because we have the positive in quadrant 1 and the negative in quadrant 4. Okay, so I'll have two solutions here, two solutions here. That will be 4 particular solutions. Now, for the general solutions, I'm going to work from those particular solutions. So I need to first remember the period of sine is 2 pi. Okay, so my first angle here was 0 and my second angle here was pi. So if I use that and I say theta is equal to 0 plus 2 pi k, and theta is equal to pi plus 2 pi k, well, would that just not be, would that not just summarize to theta is equal to pi k? And I'm going to let you think about it for a minute and see if you can figure it out, right? And by the way, we always want to say, right, k is an element of the set of all the integers. So if k is 0, theta is 0. If k is 1, theta is pi. If k is 2, theta is 2 pi, etc., 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 okay? And then we still have to deal with that arc cosine of 1/3. So we could use this version of it, but I'm just going to go ahead and use this version of it. Well, let's just do both of them. So for this version of it with the arc cosine, I would say theta is equal to plus or minus the arc cosine inverse of 1/3 plus 2 pi k, and that in a decimal version will give me, then I will put the about, right? Because now I'm rounding when I do the decimal, plus or minus 1.231 plus 2 pi k. Okay, one of those two will be your solution, your general solution for that. Okay, that's example 1. Moving on to 2. Okay, so for example 2, we're going to solve the square root of 3 tangent of 3 theta plus 1 equals 0. Okay, so when I'm looking at that, I'm thinking, okay, let's isolate that trig function first, right? So I'm going to subtract a 1, divide by a root 3. So that will be tangent of 3 theta is equal to negative 1 square root of 3. And when you're looking at that, where is that tangent equal to negative 1 square root of 3? And when you're looking at your unit circle, that would happen right here and right there. So it would happen when your angle is 5 pi over 6 and when it is 11 pi over 6. Okay, so let's put that in. So now we have to be careful also. This is not just a theta, it's a 3 theta, right? So what I'm saying here is that 3 theta is equal to 5 pi over 6, or 3 theta is equal to 11 pi over 6, because that's the angle that will give me the tangent of that 3 theta is what gives me negative 1 square root of 3. So we're going to say, okay, 3 theta is then equal to 5 pi over 6, and 3 theta is equal to 11 pi over 6. And when I divide by 3 on both sides, I'm going to say theta is equal to 5 pi over 18 and divide by 3 on both sides here. Theta is equal to 11 pi over 18 as well. Okay, so those are my particular solution. We're going to ask ourselves, see, we're dividing by 18 now, so now we're wondering, but are those the only solutions? On 0 to 2 pi on that interval, right? We want to know, are those the only one? And they're not. And we're going to see that in a little bit, but they're not the only one, right? So now we're going to do the general solution. So we're going to say period of tangent is pi. And if the period of tangent is pi, I'm going to take that and I'm going to say then my angle that was in my tangent right there, right, was 3 theta. So 3 theta will be equal to 5 pi over 6 and then plus my pi k, right? And the reason I have to do that is because this in here was not just a theta, it was a 3 theta. So it has to come here as a 3 theta is equal to 5 pi over 6 plus the period multiplied by, depending on how many revolutions I'm doing, right? But now I need to divide everywhere by 3 to see what theta is really equal to, right? Because theta is my variable, that's what I'm solving for. So I need to divide by 3. So theta equals, divide by 3 means you divide everywhere by 3, right? So I'm dividing 5 pi over 6 by 3. We already did that, gave me 5 pi over 18. But I also need to divide pi k by 3. So that will be pi over 3k. So that will be one of the general solution. And then we have another one, which is this one. But this one is actually going to be involved by, with those k's here, that's actually going to be involved there. And by the way, I need to say k is an element of the set of all the integers. Okay, now that I have that set up, I want to figure out what are all the solutions really, right, on the interval from 0 to 2 pi. So let's do that. So we're going to say on interval 0 to 2 pi. Notice how we never include the 2 pi, because if you're thinking about the unit circle, you start at 0 and you go all around, and you come back here. The 2 pi and the 0 will be at the same point, right? So that will be a repetition. So we don't include that 2 pi because it's already included right there, okay? Now, the very first one I had was 5 pi over 18. So when k is 0, the first solution I have is 5 pi over 18. When k is 1, that will give me, and I'm not going to do all of them, right? Because once you see how it goes, you should be able to figure that on your own anyway. But 5 pi over 18 plus k being 1, I'm going to add pi over 3 times 1, right? So I need to have a common denominator. So I need to multiply by 6, multiply by 6. So I have 5 pi plus 6 pi all over 18, right? So my next solution here will be 6 plus 5 is 11. So 11 pi over 18. And that's what I told you that I said this solution is going to be included here, right, with the k. Okay, now we need the next one. So when k is 2 now, so what happens when k is 2? Well, we're going to have 5 pi over 18 plus 2 pi, right? When k is 2, pi times 2 will be 2 pi over 3. And I need still to have a common denominator, so multiply by 6, multiply by 6. So that would be 5 pi plus 12 pi all over 18 now. So that would be 17 pi over 18. So that's your next one. And you're going to say, well, how do you know when to stop? Well, remember, we're going to go all the way to 2 pi. So if I have a denominator of 18, the 2 pi will then be equivalent to 36 pi on the top, right? So I'm going all the way until I have something that's less than 36 pi, okay? And you can do that on your own. I'm just going to write the other one down. This one should be 23 pi over 18, and then we have 29 pi over 18. And finally, we're going to have 35 pi over 18. And that will be all the particular solution of square root of 3 tangent 3 theta plus 1 equals 0 on the interval from 0 to 2 pi. And did I write down somewhere that, yeah, k has to be integers? Okay, here comes another one. Example 3. Okay, so we have a cosine to the first power of x plus cosine squared of x equals 2. Oops. And we're going to solve that from 0 to 2 pi only this time. We're not going to do a general solution.